It's better known to everyone as RFID. So what we are gonna take an overview of this RFID, then we'll get into like technology internals, like what are the different tags and readers are available, what kind of protocol are there, what are the different middleware architectures are there. So being a RFID, by looking at it, it looks like smaller technology, but actually at the back end it's quite a complex technology you could actually implement. So when did this actually RFID came into existence is like if you will consider where we got this inspiration to invent RFID. So it was like if you consider 70 or 75 years ago, it was a case in a marketing or product marketing that if you go to purchase any vehicle, so you can have any color as long as it's black. So it was actually sarcastically being said that you can have any color as long as it's black. So and but nowadays it's product marketing is like you can have actually you can add actually consumer flexibility. Then you could say customer can actually see a different colors, they can choose it, they can modify it. So that kind of product marketing is being done in today's world. So what is the effect of manufacturing? So actually nowadays we need to ensure that whatever manufacturing is done is actually error free. It's actually we could say custom assembly should be there. Then we need actually inventory of each and every component for the various customization option. Then we could say there are some of the critical issues that could be that we need to understand while understand the marketing of today's world. So some critical issues are like assembly process control, then inventory management, then support chain integration, then kind of customer insight. So for all this kind of thing, there is one thing you could actually integrate is actually your RFID. Okay, so this is a solution that has been supplied to you by a technology. So what is RFID then? So RFID is actually simply radio frequency identification. So we all know this RFID is what? So we have seen everywhere nowadays. So RFID is radio frequency identification. All right. So RFID is actually called as a ADC technology. Okay, so in general, what is ADC? So it's not an analog to digital conversion, it's actually called as automated data collection. Alright, so it's actually one of the type of that automated data connection technology. So what is this ADC? So these kind of technology are uses actually radio frequency waves to transfer your data between your reader and movable item like like you could actually identify it, categorize it, track it, and it's actually quite fast and doesn't require your physical site, or you could say contact between your reader and your scanner. And you already know that how the process goes, like you have one tag and you have one reader. So depending upon your reader can read multiple number of tags. So they are actually fetched with some kind of unique keys or unique tag is there. So that's why when you will scan that, you could actually get access to an information or some kind of information. So they are actually quite fast. They do not require any physical contact between your reader and scanner and the tagged item. Okay, so then even the performs operation using like your low cost components. So nowadays cost of these kind of tags is quite low. So and even attempts to provide like unique identification, then background integration that actually allows you for a wide range of application. Okay, so even if you will say this is a ADC, so again if it is automated data collection, if we are saying that RFID is our automatic data collection kind of technology, then in that case we could even we need to actually consider two different things that we have already seen. So that are actually barcodes as well as your OCR, optical character recognition. Okay, so these are also called as a technology that are being used uh, before invention of your RFID. Okay, so let's move on with the actual scenario, that what are the different system components of your RFID. So in general, if I need to draw something for the system components, so in general I would have some kind of tag would be there, basically having some kind of antenna. I would say it's inbuilt antenna, so it's a RFID tag. Alright, again this is a tag, so obviously I don't need anything but a receiving station. So there is a RF antenna, and beyond that I'll require a RFID reader of some kind. There are actually many types of RFID reader are available. Then again next should be your patch of network. Alright, so there has to have a network through which it could actually give you associated information. Okay, so there could be Ethernet or anything like that, and there has to have one terminal. So this is actually a alright. So after reading that, then information must go to your transaction data store. It's not transmission, it's a transaction data store. Alright, so once you have these kind of transaction data stores, obviously it should go to some kind of server. So they are actually referred as ONS server. Alright, and it has to associate any information that is being related with the application system. Alright, then I suppose we left with something like tag and item relationship, tag and item relationship database. Obviously there has to have information which is actually fed back from this application system to directly to your this information. Okay, so these two diagrams what we are drawing, what we have seen previously, a basic system components and this logical view, that must make a sense. Okay, because that there has to have a connection between these, otherwise it will not create any logic to have a system like RFID. Okay, so here is actually our what we could say, there is a PML. So in general what happens here is actually product information is stored here. Okay, and again ONS server must be connected to what we could say for a trading partner system. Alright, and again there has to has a connection between these different things. So whenever these kind of diagrams or diagrammatic approach you will draw, then only you will understand what are the different stages. So obviously in a sequence I have drawn, so no need to write a number, but still if you face any further issue, so for that you'll require to have different numbers for these logical diagrams. So that's why 1 2 3 4, then 5, then 6, then 7, then I could say this one is actually your 8, this one is 9, this one is 10, then this one is actually 11, and this one is 12. So out of this I could say if you need to differentiate, so this is up to this is actually your tag interface. Alright, and beyond this to up to like application systems, we have a RFID middleware. Alright, and the third segment is actually considered as other systems. So these could be modified at any point, but other architecture remains same. So this is actually logical view for your RFID. So it gives you a better idea that how your RFID manages information. So we just understand simply like there is some information being stored in RFID. We'll scan it, we'll get some information, that's it. But no, there is actually a quite complex mechanism behind it. So this is actually a way to understand. This was a previous system, it was a basic what we knew, and this is actually a backend of that RFID. All right, so next, so I think you might have gone through these kind of different diagrams. So what is this thing? So this is actually your RFID tag. All right, so what is this? So in general, this you could say this is considered always as substrate. All right, and we could say this strip is called as your antenna. So these kind of antennas actually they could be printed, etched, or stamped. All right, so there are different mechanisms to which you could actually, if you want a durable kind of thing, you want a fixed kind of thing, so that kind of things can be done. So if you want to etch it, you can actually etch it. If you want to like print it, you can print it. If you want to stamp it, so even that could be done. So these are actually your antennas, and this is your actually RFID chip which is actually attached to your antenna. All right, so it's actually these are actually like paper labels to which this RFID is being sticked. So even like these type of tags are being associated. So there are actually various applications of this kind of RFID tags. Even like you could put anywhere. So these are actually, we could say, in a in kind of a paper box you could attach inside some caps for your bottles. You can put it like for your sandals or whatever shoes and all those things, wherever wearable devices you use, you can utilize there. Even inside your clothings you can incorporate that thing, and it's actually depending upon application tracking and all those things can be done. So what are the tags and what are the different types? So tag can be attached almost to anything, almost. So you could consider any application and you can attach it there. So it could be like different items, different cases, or we could say pallets of your products, then high value good, like if you have something like some costly item is there and you want that thing to be tagged, so you could actually tag to that. Then there could be a vehicle, there could be different assets, livestock, or any personal item. You could actually put a tag on it. Okay, so there are actually we could say there are two types for this tags. So there is actually passive tags and there are active tags. Alright, so as name itself suggests everything, so passive and active. So passive actually do not require power. They actually draw it from actually a interrogator field. Okay, so these do not require a power. Okay, so I'm not incorporating all the point, I'm not writing actually all the point, so understand a completed sentence. So whenever I'll write like a passive tag, they do not require power, the explanation is actually you could draw that kind of power you want for these kind of tags from an interrogator field. So I'll let you know what are the interrogator field and why this word has been introduced. And this second most thing, so okay, I'll just compare it so that it will be easy for you. So for active tags, they are actually battery powered. All right, so yes, we could say these passive tags have kind of lower storage capacity. So and these are having actually higher capacity of storage. So how much? So here it comes like a 1 KB almost, and here it comes like 512 KB. Okay, so even like read range for these devices is different. So passive tag obviously will have a shorter read range, and these will have a longer, we could say, longer read range. So if you want a exact thing to be known, so it could be almost like approximately nearby to like 15 feet, we could say. From 1 inch, we could consider from 1 inch to like maximum up to 15. So here it's a case like you could have almost like range of 300 feet almost. So these actually passive tag, you could say, they are actually read only kind of tags. So once the information is burned inside them, they'll be useful for that thing only. They are not reusable, or many reads could not be done. So once you write, they could read many, and otherwise or read only tags are this. Okay, so one write. All right, but here it's actually a advantage. It can be rewritten using we could say rewritten using interrogator. Okay, so cost is like few hundred, and this could be in 1,000 maybe, or we could say nearest to 100, near to 1,000 kind of. So depending upon market, or depending upon what kind of tag you are expecting, this could be comparable. So in general, we could see that these depending upon what kind of application you want to explore, or what kind of application is expected, depending on that you could consider that yes, which tag is actually useful for me, passive or active. Okay, so we have seen kind of different tags. So obviously we must know what is actually instead of getting into a tag memory, basically we would require to understand what is actually we could say, we could draw a block diagram for this thing, RFID tag. So in general, RFID tag would be like there'll be one antenna. All right, then they should have some power supply. This is general. Okay, then there has to have some transmitter modulator, there has to have receiver demodulator, again there has to have we could say finite state machine, FSM should be there, or in general this is FSM, or you could write it as control logic should be there. Okay, so if you don't understand FSM like finite state machine, you could simply write control logic should be there, and there has to have a memory. So instead of just writing memory, we generally prefer to write memory cell. Okay, so this is actually your tag integrated IC, or integrated IC integrated circuit. So you could say tag IC. Okay, so these components could combine it to your entire tag block diagram. All right, so this is actually a quite generalized stuff. So I'll move on with RFID tag memory. So what are the different types of tag memory are there? So in general, for tag, there are actually three different categorization for these kind of memories. So there is actually one memory which is called as read only tags. So these kind of tags is being assigned with some tag ID during your factory manufacturing, that could never be changed. So obviously you could understand they are only read tags. So once during manufacturing tag ID is being assigned, that could not be changed. No additional information can be assigned to that particular tag. Alright, so in a short, if I need to write read only, so I could write sorry, so for this read only, in a shortcut I could say ID could be assigned during manufacturing. Okay, and second point was, I think I could say no additional data could be added. Alright, so or you could not modify the information to a tag. So next type is actually write once. This was also actually write once. During manufacturing it was write once, read many. So these are actually well known as warm type tags. Alright, so write once, read many, so that's why worm. Alright, so data can be written once, like tags is actually locked once data is written, and it is actually similar to like your CD or DVD. Okay, so you would say what is the difference then? So you could say these are actually only read only. So but this can be actually done, actually we could say you could assign some information once, but during actually packaging or manufacturing. Okay, so this point slightly modified packaging and manufacturing in any case. Okay, so these are actually, and somehow I could say worm tags are actually you might have used somewhere. So one of the important type is actually your read write tags. Okay, so these tags data can be changed over a time. Okay, so data could be modified. All right, so and actually you could say part, or we could say all of the data section can be locked. You could actually partition among it, and you could actually lock the particular thing, that yes, this particular segment has been locked and I don't want this information to be modified. Okay, so these are actually three different types of tags which are actually available in the market. Even if it is a RFID tag, then obviously there are multiple different readers available in the market. So what are the different functions of this reader? Okay, so in general, to reading an information, that is the first thing. Second, I could say there has to have they must be able to remotely power your tag. That is actually one way to supply actually power, like in a, you could say in a passive tags. Okay, so for passive tags you will require to have some supply to be given, so that's why we'll require these readers to supply some power. Okay, so that has to be obviously remotely. Then we could say establish actually bidirectional link. All right, then there has to have a inventory tag, like filter results, then communication with the network server, and these kind of reader can actually you could say they can scan like 100 to 300 tags per second. All right. So actually they are actually depending upon or depending upon requirement being suggested by a user. So these so depending upon that you could actually read the information, or you could supply uh, remotely to them, even at some distance that could be done. So obviously it's advantageous that from distance of like some feeds, if you can transfer a supply or share a information, so that is actually a kind of important thing. So what I could say, yes, I just forgot to mention one point that RFID, I was actually repetitively saying that there are some kind of interrogators are there. So RFID readers are generally referred as interrogators. All right. So these so whenever sometime if someone asks you that there are RFID interrogators, so you must not get conflict between whether he's saying about tag or reader. So interrogators are generally referred as your readers. So RFID interrogators can be actually, we could say, at a fixed point, like you could say at entrance or at exit point or at a point of sell. So depending upon application, so if you will use it at some your toll plaza, then obviously entry and exit point will be covered by these kind of readers. And readers can be you could say even uh, if these kinds of things are there, then depending upon that you could say that they are of two types, that one is actually your fixed one and other one is your mobile one. Okay, so fixed one you have seen at a toll plaza, and movable you could say like your barcode reader. Okay, so these are actually different types. And actually in general if you would say I want to see an anatomy of these kind of readers, then in general there will be like DSP will be there, then there will be some network processor, then there has to have some RF generator. So in general uh, there are actually different radio waves that are to be generated. So there is actually 915 megahertz radio should be there, then 13.156 megahertz radio is there in some of the things, and even there has to have a power supply to control all these functionalities. There has to be a control circuit. So this is actually a different aspect of this radars. Okay, so if I'll say at the by the point of RFID applications, so I could say I could use it in kind of, we could say, assembly line unit. In assembly line I could utilize this kind of thing. Then even like some of the handheld applications are there in which I could do that thing. For shipping, for larger shipment I could utilize this kind of thing. So these are some of the basic applications. So if I want to know in detail that yes where I could use, so I could say in manufacturing, and we could say in a processing also we could utilize it. So like for your inventory, production process monitoring, then warehouse order fulfillment, so these kind of thing can be done under your manufacturing and processing. So even in like supply chain management you could actually utilize it there. So like inventory tracking system and logistic management, for that you could actually utilize this RFID. Like in, even you could say in retail also you could utilize it for inventory control, customer insight, then kind of if you have seen some of the grocery stores, like they have auto checkout with actually reverse logistics and all those things. So that kind of thing should could be there. Then even in security you could utilize your RFID for kind of access control, then counterfeiting or theft control, or some kind of prevention should be there. So that kind of thing you can actually use for your security. Even like if you want to track some kind of location for some device or something like that, so whether it's traffic movement control or parking management, even like your wildlife livestock monitoring, or even in tracking. So there are actually hell lot of applications which are actually where you could utilize this RFIDs. And even like there are some of the, we could say, smart applications are there. So there is actually like smart groceries. So you can add actually RFID tag to all the items of grocery, and as your car, what we could say, your grocery cart leaves your store, it will pass through a kind of your RFID trans receiver. So the card can actually we could say rung up in kind of second. So you will not require to wait for some time. So actually it will totalize your cost, you will pay, and you will just leave it. Even there is actually kind of a smart cabinets are there. So tags are items are actually tagged in actually your smart cabinet, and they have been tagged with some ID with some appropriate space. And your smart cabinet actually periodically interrogates to access inventory, whether the thing is available or not. So kind of cabinet could be used in some kind of we could say at your home also, you could actually use it. So how this happens is actually your server or database actually updates to reflect your items utilized or disposed. Even like designated individuals can actually notify regarding the item is needed or not. So simply like if you have a rack in which you have different sauces, so out of which you some of the ketchup gets over, so he will let you know that after the inventory I got to know that this particular thing is not available in that particular shelf or cabinet, so you need to get it back. So even there are actually things like a smart freeze is there, so it could actually recognize what has been put into it. Even it could arrange like what are the things that have been removed from fridge. Even like automatic, we could say if I have some kind of vegetable is not there, so in that case I could say whether it has been removed, or whether I need to order that particular thing, whether I need to carry something, or it has been a 4 days, and whatever vegetables and all those things are there, if they are actually not in a good condition, or they are not eatable, in that case whether I should use it or not, that kind of information can be sent to you with your app, and all those things can be done using these things. So even RFID is actually a kind of part of your IoT. All right. So these tags nowadays, they are actually not much costlier, so you could actually tag your item, and actually you could make it kind of things quite easy. So nowadays even there are some of the fridge like they show you a recipe that is actually closely matchups with your fridge, whatever items are being present in that particular fridge. So it's like there are actually 2-3 vegetables are available. So by making some kind of combination and all those things, they will let you know that yes, this kind of recipe could be made. So it's actually quite a complex operation, but you could understand that how the technology is actually improvising, and how these RFIDs and all those things combinedly could be utilized for something betterment. So even like we could say some of the more smart applications are like smart appliances are there, smart products are there, smart papers are there, then smart currency could be there, even there are some smart peoples are there. So I could say if I would consider one by one like applications or of this smart RFID, in that case we could say in a smart appliances also we could utilize it. So actually closets that could give you advice or style depending upon what clothes are available. So just like the similar things that that was being with your fridge, So here there are actually clothes in your closet, so depending upon that, it will suggest you that these are the clothes available, so this could be best suited on you, or this clothings you had been used previously on in a previous week or previous day, so avoid that thing. So even like smart products are there, like it could be used for appliances, CDs, or any store is there. So depending upon what are the different appliances or things are available, you can tag those things. Even like smart paper in that thing, you could not utilize it everywhere, but you could say in airlines ticket, you could actually embed that thing, and actually they would indicate your location in the particular airport. So if you are lost, then airport authority will guide you through a proper media to get back to uh, appropriate channel. So even like smart currency, so anti counterfeiting and kind of tracking could be done. So it was initially just like while it was 2000 rupees notes in India, it was actually announced that there will be that kind of note. So it was being said that inside there is actually a RFID tag, but it's actually not there, but you could actually do that thing. So it depends. So there are actually, we could say there are few or we could say there are many advantages of this RFID over your barcodes. So basically we could simply say that first thing is non line of sight operation is there. So line of sight operation does not require. So even I could say uh, one single item at a time, which was actually a case with your barcode. So in this case of RFID, we could say multi item can be actually read in single scan. Alright, so this is actually advantage. Even we could say your each tag could have a more information. Okay, so simply like if you embed that particular thing on your milk related product, so how much or bakery product, so on that information you could store it in RFID, and you could say that this was manufactured on day before, so it will be best to use on day after or something like that. So after that it will be of no use, so it will set you kind of a, even that app could be created and it will let you know that yes, this is actually useless for you to use today, so better don't use it, throw it away. So that kind of thing could be done. Even like uh, uh, individual items actually we could identify, not just a category. So like whether it comes under a particular category or that particular individual item is different, you could actually do that. So even like you could say your passive tags have actually virtually unlimited lifetime. So kind of once the information being incorporated into that passive tag, so it will be there for a lifetime. But for active tags, if you want simply like repetitively you want to change the information, so active tag can read actually from a greater distance, so they do have their own advantage and disadvantages. So you can actually combine this RFID technology with your barcode. So it's not a big deal to be say that RFID cannot be used along with barcode, so you can utilize it. But RFID itself does have much of, we could say, different things for you to utilize it as an application. So even I could say if I need to consider communication between this tag and reader, so how that diagrammatically could be drawn. So it's like, consider this thing to be a tag, so there are actually numerous tag could be there. All right, so these are your tags. So basically these are actually one segment of your communication, and obviously there has to have a reader. So you have tag, you have reader, with reader antenna. Alright. So in between that, what will happen? So in between communication channel is actually, we would consider, so this is actually your we could say RFID communication channel. Alright. So in which actually you would get, first thing is you would get a power. You would get power from RF field. Next would be like some command or action, or we could say reader will throw you some tag command. So tag will give you like it will give you a reader response. Okay, so these kind of actually handshaking mechanism, and kind of handshaking we could not say, there is actually a directly order, whatever you have you need to respond with it. So in this case it's actually simply like first power, then command, then tag will have like, yes boss, I need to share with you some information, so it will share with you. Okay, so in general RFID communication, how does it happens is like host manages reader, and actually it issues a command. So reader and tag communicate via your RF signal. Okay, so the carrier signal generated by a reader and carrier signal sent out through this antenna, and it will hit your tag, will be a same carrier signal. Okay, so obviously in whichever circuit the carrier signal remains one only. So whenever actually signal is generated, it will be combined with your carrier. That carrier will be sent through your antenna, it will hit your tag, and obviously tag will receive something. It will kind of, you could say, it would modifies your carrier signal. All right, then it sends back your modulated signal like passive backscatter. It is actually also referred as your field kind of, it is also said as field disturbance device. Okay, signal sends it back to your reader, and reader will decode that information, and it will result to that kind of host application, so whatever is being intended. So in general these are actually basic mechanism of your RFID communication. All right, so there is actually one more thing which is called as actually antenna field and operation frequency. So actually these are different points. This is actually one segment and this is another segment. So first we'll see what is actually antenna field. So actually you could say this antenna field can be divided into two different parameters. So one is actually, we could say, inductive coupling. Okay, and another is actually propagation coupling. So you must understand the difference. Okay, so in general, if you would consider a diagrammatic approach for both of the things, so it will be simply like there will be a kind of trans receiver tag, a reader. Okay, here it will be some kind of antenna, and here it will be like your RFID tag. Alright, obviously it will be associated with some kind of chip, which is actually important part, or we could say it's IC or a microprocessor, you could say, and you must have some kind of antenna should be there with that RFID tag. So whenever it's a propagation, in that case it will be like or sorry, this is actually inductive coupling. Okay, so coupling, and whenever it will be a case of your propagation coupling, in that case entire scenario will be similar, but only thing is the signal will be propagated. All right, so signal getting propagated and signal getting like we could say inductive coupling, there is a difference. Okay, so in this scenario it is like in a inductive coupling we could say these are actually kind of passively you're doing this thing, and this is actually we could say in an active tag it's generally preferred, but we could not surely say that yes this is for active and this is for passive, kind of thing doesn't happen. So there's depending upon what kind of application is there, how much distance you want to cover, so depending on that it could be used, but in general that is being said that this is used for your passive and this is used for your active. So for passive it's actually good to have a inductive coupling. Okay, it's good to have a propagation coupling where you want a more distance, so in that case you could actually use propagation coupling. All right, so there are actually different frequencies, you could actually consider that kind of thing for your different application. So I have actually divided it among I could say four different frequencies. So frequencies are like low frequency, there is actually a high frequency, there is actually a ultra high frequency, and there is actually a microwave frequency. Okay, so low frequency means what? So like 125 kilohertz, and then high frequency is like 13.56 actually megahertz. Alright, ultra high frequency is like it's a band of 868.915 megahertz. So its microwave is like 2.45 giga to like 5.8 gigahertz. Okay, so these are actually four bands in which actually your operational frequency you could consider as these four frequencies. So low frequency, high frequency, ultra high, and microwave. Okay, in these bands you could actually make your RFID tags. So we could say depending upon these frequencies, obviously the thing will vary is like your distance. So first thing, if I would consider a range of read, so it will be like 1 to 12 inch. In this high frequency I could say almost around 24 inches. Okay, so in next case I could say uh, almost like medium range, or we could say moderate, and even in next is actually like so I could not say so consider this to be 1 to 12 inches. This is so I could say in general I could say I don't remember exact values of this thing, but this is actually considered as short. This is actually a shortest. This is short, this is we could say medium, and this is actually a longest. Okay, so actually depending upon your wavelength your range is actually increasing. So I don't exactly remember these distances, but yes I'll come up with that thing. But I suppose these are actually generally considered as shortest, short, and medium, and longest. I do remember a value, but I don't understand why these are actually in inches. Okay, fine. So next one is actually the power sources. So generally we could say with the low frequency generally they have passive tags only. Okay, so actually they do use a inductive coupling. So actually there are actually more couplings, inductive, capacitive, and all those things are there. So in low frequency actually it uses inductive coupling for we could say I could write inductive coupling. For high frequency I could say they are using actually inductive or capacitive coupling. And for ultra high I could say these are actually they do have a integral we could say to generate these kind of high things it could not be generated through a reader. So that's why we require actually active tag and actually an integral battery. So we could say e-field coupling could be utilized here. So that's actually with your this thing, and that is the same thing with your microwave also. So there are actually active tags with integral battery, or we could say passive tag, even using capacitive storage or e-field coupling. Okay, so these are actually some of the things you need to remember. All right, so actually we could say data rate is actually even same as that of your distance. So we have actually slow, here we have a slower, here we have a moderate, here we have kind of a we could say it's actually a fast, and this is actually your fastest thing. Okay, so even like if you have kind of metal or wet surfaces, so will it be fine that your reader will be able to do these kind of things? So that is actually one of the important parameter, that if you have a metal characteristic or the surface is actually wet or it's underwater kind of thing, so in this case of low frequency, this is actually inverted thing. So this will work better with a low frequency. This is actually, we could say, moderate in high frequency, but at a as soon as your frequency increases, your performance with your actually ability to read near metal or wet surfaces, so that will get poor actually. So this is poor, so this will be actually, we could say, it will be worse. All right, so even if I need to say some of the application for these operational frequencies, so I could say the first one would be like access control or security identification, or kind of we could say, if you want to deploy it on some kind of animal, or even like for an employee ID you want to deploy, that could be done. The second thing, high frequency, could be we could say in library books, or in a laundry, or some kind of access control employee ID. So even these are actually nearby to same. So now you will say where we could use actually your UHF. So this could be used in your actually supply chain tracking or highway toll tags. So there we use actually UHF. Okay, so now microwave, then again this could be similarly used in your highway toll taxes for payment of that thing, or for identification of your private vehicle fleet in and out of yard, or facility asset tracking, that kind of thing can be utilized. So these are actually different four bands in which, actually depending upon your requirement, you could actually deploy these kind of things. So actually your reader do have some kind of functionalities. Okay, so like how the tag power is transferred. Okay, so in general, if I do need to create some mathematical model for this, so if it is kind of a reader, then I would say it's a tag. So if I would say it's a tag, so they do have a separate separation distance of d. Okay, so the question is, if a reader transmit kind of, you would say, PR watts. Okay, so if it is PR watts, then how much power we could say PT does the tag receive at your separation distance of D? So here is actually power by transmit power. Actually we could say PR is your reader power, or actually readers transmit power. Okay, and PT is actually it's actually, I could say, I have wrongly put that scenarios. So this is generally we refer it as transmitter and receiver, but here it is a reader and actually a tag. Okay, so now in general, if I will say, I'll repeat my question. The question is, if reader transmits PR watts of power, okay, and the separation distance is D, and received power is denoted as PT, so how much power PT does tag receive at a separation distance of D? So in general, it will depend upon what frequency you are using. So for example, if I am using UHF band of frequency, which is actually your 915 megahertz, okay, so in that scenario, this is actually called as your far field propagation. Okay, so far field propagation. So in that case, your formulation is like power that is being received at a tag will be proportional, or will be proportional to 1 by d square, or inversely proportional to square of a distance. Okay, so in general it will be case with your UHF. So in general, if I would say, what if it is a HF or high frequency, which is actually 65, no, it's actually 56, I think, yes, 56 megahertz. So this is actually your inductive coupling, so obviously it will be a nearest distance. So in that case, formulation will be d raised to 6. So obviously from these kind of formulations you could easily understand so how or how much power is being induced or will reach your tag. All right, so actually we could say there are actually many limiting factors are also there for your passive RFID tag, since like even we could say, if I'll again write PT is proportional to 1 by d raised to 2, I'll consider. Okay, so it's actually doubling a read range. It will require actually your 4x of the transmitted power. So this is actually, we could say, this is actually an implication, I would say, not a limitation, but I would say this is an implication. Then obviously the larger antenna can help with these implications, but again at the expense of larger physical size, because actually if you know, g of t comma r is actually proportional to your area. Okay, so that's why obviously larger antenna could be deployed at the expense of your larger physical size. Okay, there is actually one more thing we could say: the more advanced CMOS process technology will actually will help by reducing PT. Okay, so at the large distances, even radar sensitivity we could say limitations actually dominate. So these are actually some of the implications. So if I'll talk about limitation factors, and limitation factors are like reader transmitter power, which is actually government limited. Okay, so reader actually receives sensitivity, that is SR. Then again reader does have some kind of antenna gain, which is actually again limited by something. Then tag antenna gain, which is actually GT. So power required at tag PT, which is actually silicon process limited. Previously the tag antenna gain, which is actually, it depends upon what is the size, so it is a size limited. What we discuss is actually power required at antenna, or sorry, for a tag it's actually PT, so it's actually depends upon your silicon process limited. Then again we could say there is one more limiting factor for your passive RFIDs, your tag modulator efficiency, ET. So these are actually different limiting factors for your if at all it's a passive RFID. So while picking up some kind of antenna, you need to always understand what are these differences between these different antennas or different RFID readers, what are the different standards they have been designed. Because for even for your RFID there are some of the standards that are being designed. So it is actually it's CEN 30220, its standard is there for your RFID, which is actually shared operation in your band of 865 to 868 kind of megahertz operation. So it's actually I'll just write down a band. It's CEN 30220 standard. Okay, so these kind of standards are there. So even your there actually RFID does have more information than this, but due to lesser scope or lesser time, I could say I am not covering entire thing, because even hello and welcome to the new topic. Today's topic is radio frequency identification. So it's better known to everyone as RFID. So what we are gonna take an overview of this RFID, then we'll